Hello students, in the last lecture we have studied some methods to prepare the colloidal solutions. How colloidal solutions are prepared, in that lecture we have studied. Preparation of colloidal solutions by using the Briggs arc method. We have studied the colloidal salts are prepared by using that method, metal salts. Secondly, we have studied preparation of colloidal solutions by the peptidation method. Peptidation. In peptidation, the precipitate is converted into colloidal solution, and first one reaction by which the colloidal solutions are prepared, that was the chemical method. In chemical method, the colloidal solutions are prepared by oxidation, reduction, hydrolysis or double decomposition method. Today we have to study purification of the colloidal solutions, and after that we will study the properties of colloidal solutions. See, purification of colloidal solutions. Colloidal solution contains excess of electrolyte, and therefore it is necessary to remove that excess of electrolyte from the colloidal solution. Some amount, small amount of electrolyte, small amount of electrolyte is required to stabilize the colloidal solution. There is use of small amount of the electrolyte. Small amount of electrolyte is required in it. But if excess of electrolyte is present in the colloidal solution, that is responsible for coagulation. It is responsible for coagulation. अगर किसी भी colloidal solution में excess of amount of electrolyte होता है, प्रेजेंट होता है, तो उसका कोएगुलेशन हो जाता है. Therefore, there should be small amount of electrolyte present in colloidal solution to acquire the charge by colloidal particle and stabilize the colloidal solution. Here see, what is meant by purification? That is the process in which reducing amount of electrolyte, and it should be present in requisite minimum amount of that electrolyte should present in that solution, and that is nothing but the purification. यानी क्या, कोलाइडल डिस्पर्शन में जो इलेक्ट्रोलाइट ज़्यादा होता है उसका अमाउंट रिड्यूस करने का, और जितने की जरूरत है उतना ही इसमें रखने का. So that is nothing but the purification of colloidal solutions. So colloidal solutions Purification of colloidal solution is the process in which reducing the excess of amount of electrolyte and it should present in requisite amount in that solution which is required, so that is called as the purification. Now here one of the process of purification we have to study, dialysis process. In this dialysis process we have to take the colloidal solution in this bag. So this is a bag containing colloidal solution, that is the dispersed phase and dissolved electrolytes are present in it, and here it is placed in this outer vessel. Okay, in this outer vessel what happens, continuously here water flowing is there, and what happens, the electrolytes are passes through the bag and they are flowing with water, so that process is called as the dialysis process. It is known as the dialysis process. So process removing dissolved substance from colloidal solution. Process of removing dissolved substance, removing dissolved electrolyte, dissolved substance or dissolved electrolyte through that suitable membrane. Through that suitable membrane means this is a porous membrane, and through that porous membrane of bag the dissolved electrolytes are removing and flows through water. This is water and plus electrolyte goes outside, and here purified electrolyte, that is the colloidal solution left. So that is nothing but the purification, and this process is called as the dialysis. Dialysis is also carried out in human being. आपल्या शरीरामध्ये सुद्धा डायलिसिस प्रोसेस केली जाते. वेन किडनी इज नॉट फंक्शनिंग, जर कुणाच्या किडनी फंक्शन करत नसतील, किडनीचं फंक्शन काय आहे की इट फिल्टर्स द डिफरंट टाइप ऑफ सबस्टन्सेस फ्रॉम द ब्लड थ्रू द सेल मेम्ब्रेन. जे काही मेम्ब्रेन आहे त्या ठिकाणी त्याच्यातून ते फिल्टर करतात, म्हणजे व्हेरियस टाइप ऑफ नॉन रिक्वायर्ड सबस्टन्सेस डझंट मिक्स विथ द ब्लड and they are removed from our body through the excretion. परंतु जर कुणाच्या किडनी फंक्शन्स करत नसतील तर काय होतं की युरिया हा ब्लड मध्ये मिक्स होतो आणि मग त्याचा प्रॉब्लेम येऊ शकतो. कुणाच्या अंगावर सूज वगैरे येते, प्रॉब्लेम येतो. मग त्याचं काय केलं जातं, तो युरिया किंवा नॉन रिक्वायर्ड सबस्टन्सेस आर रिमूव्ह फ्रॉम द ब्लड बाय द डायलिसिस प्रोसेस. So here also dialysis is carried out to remove the dissolved electrolyte from that dispersion, colloidal dispersion, to this suitable semi-permeable membrane, that is the bag. It is called as the dialysis. This is nothing but purification of the colloidal dispersion. Now see the properties of colloidal solutions. Here we have to study the properties of colloidal solutions. Now here this colloidal solution, see the properties. Colloidal solutions are made up of two phases that already we have studied. One of the phases dispersed phase, that is dispersed phase, and second phase is dispersion medium. So that is nothing but the two phases present in colloidal solution. Second property of colloidal solution, colloidal particles are slowly diffuse through parchment paper parchment paper. It is a specially manufactured paper, parchment membrane, but it fastly diffuse through ordinary filter paper. Ordinary filter paper में से वो फास्टली डिफ्यूज होते हैं, मगर parchment membrane और parchment paper में से वो slowly diffuse होते हैं. They slowly diffuses through parchment paper, but fastly diffuses, readily diffuses through the ordinary filter paper, and particles cannot easily detected. Particles cannot easily detected under the ultra microscope. So that is nothing but the properties or general properties of the colloidal solution. Powerful microscope, ultra microscope में से वो detect होते हैं. That is they are cannot detected easily under the powerful microscope. So these are the general properties of colloidal solution. Colloidal solutions made up of two phases, disperse phase and dispersion medium. Colloidal particles slowly diffuses through parchment paper, but they are fastly or readily diffuses through the ordinary filter paper. Particles cannot easily detected under powerful microscope, but the particles in colloidal solutions can be detected under the ultra microscope. They can easily detected. Now see, there are some another properties of colloidal solutions. We have to study optical properties. Optical means we can observe it, we can see it, we can observe it. So that properties we have to study. That is optical properties of colloidal solution. First one property is Tyndall effect. So this Tyndall effect, these properties are only shown by the colloidal solutions. These properties are only shown by the colloidal solutions. So what is the Tyndall effect, and some day-to-day life examples of the Tyndall effect also we have to study. What happens here? See this experiment. In this first beaker I have taken solution. It is a true solution. Okay. And in second beaker I have taken colloidal dispersion or colloidal solution. Here this is the source of light. When this beam of light is passed, that is beam of light pass through the colloidal solutions, then path of that beam of light becomes visible. That is nothing but the Tyndall effect. Path of beam of light becomes visible through the colloidal solution and invisible through the true solutions. So that is nothing but the colloidal solution. So why it is visible and invisible? Size of the particles of solute in colloidal solution is very small. They does not scatter the light. Scattering of light means they change the path of light. But here what happens? In case of colloidal solution, the light is scattered. Light is scattered by the particles present in solution. Particles present in colloidal solution, and that scattering of light by the colloidal particles in a colloidal solution is called as the Tyndall effect. You see, this is the source of light. This is beam of light passing through solution. But what happens, that beam of light through solution is not visible. यानी कि वो पाथ ऑफ द बीम ऑफ लाइट हमें उसमें नहीं दिख रहा है, कैसे लाइट जा रही है, मगर when it passes through this colloidal solution then the light path of beam of light becomes visible. म्हणजे आपल्याला ती लाईट त्याच्यामधून जाताना दिसते, इथे ही लाईट अशी दिसते याच्यातून जाताना. So that is nothing but the scattering. Why it is visible? Because the colloidal size particles present in this solution, they scatter the light, and when this beam of light falls on that particle, then there is formation of a bluish cone, and that cones are called as the tyndall cone. They are known as the tyndall cone. So scattering of light by the colloidal solution, due to which the path of beam of light becomes visible, and that is called as the tyndall effect. That is known as the tyndall effect. Few more points like the importance of tyndall effect and applications of the tyndall effect we have to study. So here see, in this tyndall effect, what that is the, when the tyndall effect is carried out or takes place, that is when diameter of dispersed particle not smaller than the wavelength of light, diameter of dispersed particles not smaller than wavelength of light, then the tyndall effect is observed. And refractive indices of dispersed phase depends on, म्हणजे dispersed phase and dispersion medium, की जो refractive indices है, they differs largely, then and then the tyndall effect is observed. Now see day to day life मध्ये tyndall effect मी सांगतो तुम्हाला. समजा रूम मध्ये पूर्वेकडून एखादी विंडो आहे आपल्या, आणि तिथे जस्ट आपण साफसफाई केलेली आहे, क्लिनिंग केलेली आहे, तर क्लिनिंगमुळे काय होत आहे, डस्ट पार्टिकल्स आर स्प्रेड इन द एअर, ॲटमॉस्फिअर मध्ये तिथे डस्ट पार्टिकल्स स्प्रेड होतील, आणि थोडेसे खिडकी जर ओपन असेल तर त्याच्यातून सनलाईट येतो पाहत, and the path of that sunlight becomes visible because that dust particles spread in the air, atmosphere, scatter the light, आणि आपल्याला ती लाईट अशी जाताना दिसते स्पष्ट, त्याच्यामध्ये त्याचा पाथ विजिबल दिसतो त्या बीमचा. सो दॅट इज द tyndall effect. This sky appears blue color. Sky why appears the blue color? Because of the scattering of light present in the dust particles. Scattering of light by the dust particles present in the atmosphere. So therefore they scatter the blue colored light. And therefore sky appears the blue color. This is also example of tyndall effect. That is also example of tyndall effect. As well as when there is fog, म्हणजे खूप धुकं पडलेलं असतं, आणि धुकं पडल्याच्या नंतर काय होतं, आपल्याला खूप असं दूरचं दिसत नाही, पण आपण ज्यावेळेस हेडलाईट बाईकचा किंवा मोटार कारचा ऑन करतो, तर ते हेडलाईटचं आपल्याला ती बीम जो आहे, ते पाथ ऑफ बीम ऑफ द हेडलाईट बिकम्स विजिबल. वाय? बिकॉज इन दॅट फॉग small particles of mist are spread or present, and they scatter the light, therefore the path of beam of light becomes visible in that form. So that is also example of the Tyndall effect. So these are the examples of Tyndall effect. See the importance of Tyndall effect. Importance of the Tyndall effect. So Tyndall effect is used. It is useful to determine number of colloidal particles present in the solution are determined or calculated by using the Tyndall effect. That is nothing but the how many blue cones are formed, how many Tyndall cones are formed, they are determined, and they are nothing but the number of particles present in it. So it is useful to determine the number of colloidal particles present in colloidal solution. And second one importance, this property, that is Tyndall effect, is used to distinguish between true and colloidal solutions. That is the importance of the colloidal solution. See the one more property of colloidal solution, that is also optical property. We have to study the color of colloidal solution. Colloidal solutions shows colors. Why they show the color? Because they absorb the light of certain wavelength. They absorb the light of certain wavelength and transmitted the light of another wavelength. Light of certain wavelength is absorbed and light of another wavelength is transmitted, and therefore they appears the color. They shows the color. Color of colloidal solution depends on the size of colloidal particles. Colloidal solutionचा कलर हा कोलायडल सोल्युशन मध्ये असणाऱ्या पार्टिकलच्या साइजवर डिपेंड असतो. डिस्पर्स फेज पार्टिकल्स. इट डिपेंड्स अपॉन द साइज ऑफ कोलायडल पार्टिकल्स प्रेजेंट इन दैट colloidal solution. Here see, this scatter the light. Mixture of few drops of milk and large amount of water appears blue. Mixture of few drops of the water and milk and large amount of water, it appears the faint blue color. कुठला कलर येतो याला? ब्ल्यू कलर. This is due to the scattering of light by the milk particle, right? As well as gold particles when finest म्हणजे very small, then it has red color. Finest, very small, that is the red color. But as the size of gold particle increases, the larger size of gold particles have purple color. So colloidal solution shows the color. Color of colloidal solution is due to the scattering of light. Actually they absorb the light of certain wavelength and light of remaining wavelength is transmitted. That transmitted light appears the color, and color of the colloidal solution depends on the size of colloidal particle. If you take few drops of milk and large quantity of water, then it appears the blue color due to scattering of blue color light. As well as when the gold particles are very small, finest gold particles are red color, larger gold particles than the finest is purple color, and larger size of colloidal particles again they have what that is the yellow color. So that is nothing but the color of colloidal solution. Some other properties of colloidal solutions like the electrical properties, how the charge acquired by the colloidal particles in a colloidal solution, that, and electrophoresis, that we will study in the next lecture.